Okay, guys, let's get going. This last example from sequences and regarding the closed formula instead of the recursive definition. So this is the second example we're seeing for the closed formula. And something like this usually doesn't come out, but it's good to know it because if it does come out, it usually will come out in a very straightforward way. Because it's a bit of a brain teaser, as I said. So they won't torture you guys in exams to figure out something which you either see or don't see. Okay, so anyway, let's explain the question. Firstly, let's read the question. Let me just clear a typo here. I see a typo. Let's take that out. That's not needed. Okay, so the question says use the formulas, and it gives us two formulas to find closed formulas for the following sequences. So the sequences are given here, 1, 2, and 3. We have to use the formulas given above, the Tn and An, to somehow find closed formulas for Bn, Cn, and Dn. So let's at least do one of them. We'll see about the others. Let's at least do one. But now to compare our sequences to the ones above, to compare Bn to the ones above, we need to see what the elements actually look like. So let's do that. Let's list out a few elements for Tn and then An. So I'll start at the bottom by listing out a few for Tn. And I think my pen is dead again. Let me just take out the battery and put it back. That usually works. But in the meantime, I think An was done already. I think that's the first example we did. So that's good. That one we can do quickly. Let's just do Tn. Well, let's hope the pen works now. Always works somehow. Anyone knows how to explain that from a physics point of view? I still don't get it. Or why hitting remotes makes them work. I still don't get it. Okay. So Tn here is given by n into n plus 1 over 2. Let's work out a few elements. T0 will be given by, just plug 0 into the formula. That becomes 0 into 0 plus 1 over 2, which is just 0. T1 is going to be plugging 1 into the formula, which is 1 into 1 plus 1 over 2, which is just 1. The 2 over 2 will cancel out and you're left with 1. Okay, I'm just going to work out a few of them. I'm keeping in mind that that's what we're working with. That's 1. T2 is 2 into 2 plus 1 over 2, which is just 3. T3, I'll just do one more. Gosh, just do one more. T3 is 3 into 3 plus 1 over 2, which is, we get a 4, a 12 over 2, which is 6. Or let's just do one more. Last one. 4 into 4 plus 1 over 2, which is 20 over 2, which is 10. Okay, so we have enough to construct some kind of sequence for Tn, which I will write above. I'll write it right here. Tn double dot. So we worked out 0, 1, 3, 6, 10, and so on. Okay, is it more or less clear what I did here to work that out? So all I did is just plug different values of n, starting from 0, going up to 4, into the formula above for Tn. Just plug n into that and get different numbers coming out, so we can form a sequence. Okay, and let's do the same for AN as well. We don't have to do this explicitly because that's a bit of an easier one to work with. And it's the same one we did as the first example. So that was done already. But anyway, you can just work this out in your head by looking at it. So I'll do that here at the bottom. For AN, if n is equal to 0, that sequence gives you 2 to the power 0, which is 1. If n is equal to 1, 2 to the 1 is 2, and so on. 2 squared is 4, 2 cubed is 8, you get 16, and so on. You're just basically doubling each number. Okay, so that part is the hard part, done already. Any questions, Pandoma? All right, okay. So now what we need to do is compare those formulas that we're given, somehow compare them to these to see if we can work out a general formula for the ones at the bottom, for 1, 2, and 3. Let's just do 1 for now. Can we work out a general formula for Bn by comparing it to Tn? Because we know Tn's formula. So what I mean by that is maybe Bn is the same as Tn, but maybe we just multiply each element by 2, or subtract 1 from each element, or something like that. Right, so we need to spot a pattern here, relating the elements of Tn to the elements of Bn. I'll give you guys a minute to think about that if you see it. I personally don't like things like this, but I know it because I saw it already. I won't spoil it for you guys. Does anyone see any kind of pattern here? Yes. That's right. Tn plus 1. That's correct. Perfect, right? Well done. Nicely spotted. So you'll notice that if you take the elements of Tn, the first one is 0, just add 1 to that, and you get the first element of this. Right? 0 plus 1 gives us 1. The second element, add 1 to that, and I should get 2, which corresponds. Add 1 to 3, I get 4, so we see they correspond. You just add 1 to Tn, and you end up getting Bn. Right, so that's how we write our answer. We would say that Bn is the same as Tn plus 1. That's how we compare these things to find an answer. And we take it one step further because we want to write this as a general formula. So we just plug in the Tn formula here, which is just n plus 1 over 2, and still now plus 1. So I'll let you guys try one more. Let's try number 2. I'll give you a minute to look at that one. Okay, so if you don't get this one, don't stress about it. I don't want to spend too much time here, but again, it's one of those things that either you see it or you don't. Spend a bit of time looking at it. If you have enough time, it can be fun. Otherwise, it's quite stressful. Yes.
A-N S. I know here, right? It's okay, 3 plus 2 is to 5, and 5 plus 2 is to 9, plus 9 plus 9. Oh, 20 minutes.
Or maybe you want something there. Okay, so maybe there's more than one way that works for these things. So the one that I know does work is if you take 2 times AN plus 1, then you will get CN. Let's just see if that's right. 2 times 1 is 2 plus 1 is 3. Yeah. 2 times 2 is 4 plus 1 is 5. So this one works. And this one I didn't work it out. Someone in the previous class worked it out. So it's one of those things, right? Sometimes you spot it immediately, sometimes you have to look at it for a while. So my point is, don't take it personally if you don't get it immediately, right? It's okay. It's all right. Because I didn't, so don't feel bad. It's fine. And also, you probably wouldn't be asked things like this in an exam because it's quite cruel. Maybe the first one, but even that it's a bit stressful. Okay, so let's just write this in the final way, which is to substitute our formula for AN into this formula that we worked out. AN is just 2 to the power n, so I'll plug that in here. Using exponential rules, we can simplify that one step further. Same base, so we add the powers, so we can write that as 2 to the power n plus 1 plus 1. Okay, number 3, you can try that at home without any pressure. Also, guys, these examples are from the module manual, so if you want to see the actual solutions, they are there as well. I think they give you like about 9 different ones to try. I've only put 3 here because some of them get quite ridiculous. It's like you take a sequence, you take the fifth power of it plus 1 divided by 3, weird things that are very difficult to think about. Yes. The third one, you can try if you want to.
Tn times 2.
Tn times 2. Let's check that dn is equal to Tn times 2. 0, 2. Yeah, you're right. That's exactly it. Isn't it? Yeah. Perfect. So we have the third one as well. Okay, well done. Well spotted. Why is the third one? Okay, anyway, that's okay. Yeah, it's fine. Makes sense. Okay, so from there, we can move on to functions. Okay. So this is the last thing we need to do this learning unit. But it's a little bit involved, so I'm not going to rush this section too much. Okay. So functions, I think today we'll just go through the basic ideas, maybe one example, and then I'm not going to kill you guys too much since it's a Friday as well. All right, so let's start with the basics of functions. We start by defining what a function is, which is a bit abstract, but it's okay. A function is a rule that assigns each input exactly one output. So you've probably seen that in high school. You've probably seen some examples of functions. If not, that's all right. Let's look at an example to make this more concrete. A function is a rule that assigns each input exactly one output. And let's look at one more definition before an example, which is the word image. So again, these are things they probably will try and catch you with multiple choice and stuff like that. So the word image just refers to the output of a function. The output of a particular input is called an image. Right, so again, that's written here, but let's try and make that more concrete by looking at a real example. So let's suppose I said f of x, let's just define a function. I don't know, is equal to 2x. Or let's say, do you guys have a favorite function? Anybody? Okay. Nobody has a favorite function. Let's just say parabola, not parabola. Okay, x squared, right? Simple parabola. Okay, so if that's our function, then let's look at some examples of images. So if I were to take an input, let's say x equals to 2, for example, filter it through the function, I will get f of 2 is equal to 4. Right? If I plug 2 into the function, I get 4 as an output. So that 4 is called the image. That 4 is the image corresponding to the input 2. It's easy to understand these with examples. Okay, we can do another one. Suppose I put the input x is equal to 3, then f of 3 is equal to 9. Here 9 is the image corresponding to the input 3. Let's just maybe put that here. The images are here. Input is here. Okay, so I'm trying to get the first two things out of the way because the next three things go together. So the first two things were definition of function and image. We'll cover that. The next three things which you can't separate, well, you can, but it's not nice to separate them, is domain, codomain, and range. So I'm guessing you guys heard about domain and range in high school, probably. Codomain, I'm not sure. Anyone seen that before? Okay, all right. So it's just like it's like a previous step to the range. So let's define these things. So domain, we know are all the inputs of a function. To be more specific, the domain is the set of all inputs of the function. Sometimes we just call them the x values. Doesn't have to be x, but so the set of all inputs of a function is the domain. The set of all outputs is the range. Yeah, you might have seen that before, the y values. The set of all outputs is the range. Now the codomain is somewhere in between that. It's the set of all allowed outputs, not the actual outputs, but the ones that are allowed. The set that tells us which ones are allowed, that's the codomain. This is one of those things where we need to see examples because it's quite abstract. You guys have another lecture after this? This is the last one. Okay. Makes me feel even more bad now. I'm holding you guys up from going home. Okay, so we'll finish as quickly as we can. Okay, so the last thing here that we need to know today is this general form of representing a function, which is shown up here in the red box, this one right here. This is something that will come up over and over again. So it's telling us what the domain and the codomain is for a certain function. The function labeled as f. It's telling us that the domain is defined right here. This part here is the domain. After the arrow is the codomain. Write that a bit better. So this need to remember, this is standard. You will always see this and it tells you what is the domain and what's the codomain. So if you're given this and asked these questions, What's the domain and codomain? You don't need to work it out. You just read it straight from here. Right? And let's look at an example now to make this less abstract. This example is down here in red. Sorry, not in red. The one in green is the example. Right here. And we see again the same form where we got f double dot something arrow something. And here they define the function as well. So this is all the information we need to answer the questions at the bottom, which are to define the domain, codomain, and range. Okay, do you guys want to try telling me what the domain is here? You must have a guess. Just by looking at this, we must read it off from the form. X squared. We close, for example, in the area. Yes. X. No, it's not X, not in this case, but again, you guys are in the area. So you just have to read it from here. It's just this, the natural numbers. Right? That's your domain. Always just read it straight from here. So all the inputs to the function are the natural numbers. That's what this is telling us. We're not worried about the function just yet. These are just the inputs. So the domain are the inputs, which are just the natural numbers. So I'll write it here. And you can write it as a set if you want to. We don't have to, but I'll write it here. 1, 2, 3, and so on. Okay, that's the domain. Again, that's why I'm saying it's easier than you think it is, because you literally just read it from up there, from the form given above. So we see n there in the place that defines the domain. That means natural numbers. So in a similar way, can you guys tell me what the codomain is? First part's the domain, second part tells us the codomain after the arrow. Anyone wants to try telling me what that is? Yes. Sorry? I think you're going toward the range now. Yeah, but that's okay. All right. So it's the same thing. If that's the codomain, sorry, if this is the domain and this is the codomain after that, then that's the answer right there, whatever is there. And that's also the natural numbers here. So it goes from n to n. So that's the codomain on that side, which is the natural numbers. Okay, and again, you can write it as a set, 1, 2, 3. Okay, so now remember the domain are the inputs. So if I ask you for the range is worked out by taking all the inputs, filtering through the function and getting outputs. So the set of outputs are the range, right? So let's just do a few of them. I'll do them on this side here. So f of the first element from the domain is 1. So f of 1 filtered through the function gives me 1 squared plus 3, which is just 4. That's the first element of the range. The second one will come from the second element in the domain, and so on. You just keep on doing that. So the second one is f of 2, which filters through the function to give me 2 squared plus 3, which is 4, 5, 6, 7. Okay, I'll just do one more. F of 3 is the next one. It's 3 squared plus 3, which is just 12. So again, these go, the set is infinitely big, right? It doesn't stop. But we've worked out 3, so I can write the range as 4, 7, 12, and so on. Again, the range is just taking all the inputs, filtering through the function, and getting outputs. And the inputs are here, the domain. So hopefully this example shows clearly the difference between codomain and range. Similar idea, but different sets. But the codomain is all the allowed outputs, but the range are the actual outputs from the functions. Okay, so the last thing we have to do, I'm not going to torture you guys to do it by yourselves. Let's just do it together in one go and get it done. Unless you guys want to try this first before I do it. Can I go up? Sure. Welcome. So here, these examples are just to make clear how to get domain, codomain, and range. 3 examples so we can see them from 3 different perspectives. So let's look at number 1. From number 1, can you guys tell me what the domain is? Same idea as before. If you're wrong, it's okay. I will guess. Correct. So again, guys, it's just like that. You just read it from here. Whatever is there is the domain. Right? So that's integers. Right? Remember, Z represents integers. So the domain here are the integers. I'll write it like this. Dot, 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 -2, -1, 0, 1, 2. You could just write Z if you wanted to, but I'm just showing it as a set to reinforce the idea that these are all sets that we are working with. Anyone wants to try to tell me what the codomain is here? You can just read it from above. So this always tells us domain. That other part after the arrow always tells us codomain. So here the codomain is also the integers, right? It also is given by Z, which is integers. So same set, -2, -1, 0, 1, 2. Finally, the range is worked out by just filtering the inputs or filtering the domain into the function given above. Right, so again, this is an infinitely big set, but let's just do a few of them. If I filter -2 into the function above, I will get 3 times -2, which is -6. So I'll write that here, -6. If I filter -1 into the function, 3 times -1 gives -3. Filter 0 into the function, I will just get 0. And so on, I'll get 3, 6, and so on. Okay, maybe I should write that on the side in case I lose anybody. So all I did is filter -2, the input into the function, and I get 3 times -2, which is -6. Filter -1, I get 3 times -1, which is -3, and so on. 3 times 0 is 0, dot, 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 and we just keep on doing this. So that's how we get the range. So this is how we work out the range. Filter into the function above. Okay, now we're almost there. Just 2 more examples, and there's nothing really to work out here. We just have to see things by inspection in these 2 examples. Okay, first, any questions on the first example? Okay, let's just cover that one up and go to example 2. Can anyone tell me what's the domain for this example? 1, 2, 3, exactly, right? That's all it is. You just read it from the example itself. It's the set 1, 2, 3. Perfect. By the same logic, can you guys tell me the codomain here? ABC, exactly. Thank you. It's just ABC. Now, usually the range is worked out by filtering our inputs through a function and getting outputs. But here we're not given an explicit function. It's probably because maybe it's a discrete function. It might be something strange. We don't know, but it doesn't matter because we are given the outputs here, right? We are told that if you filter 1 into the function, you end up getting C as an output. So that means C is our first output, right? I get that directly from the top here. I'm just reading it off. I filtered 1 into the function and I got C as an output. Right? If I filter 2 into the function, I get A as an output. So A is my next element of the range. That's given here. And similarly, if I filter 3 into the function, I get A as an output again. That's the range. But now remember, repeats don't matter in set theory and order doesn't matter. So I can just discard the repeat A and change the order to make it alphabetical. Right? We can do that because order doesn't matter and repeats don't matter. Okay, last example before I let you guys go. Can someone tell me the domain here? 1, 2, 3, perfect. Codomain? Perfect, 1, 2, 3. Now the range here is given in a strange way. They give us the functional outputs in terms of a diagram. So what they're telling us here in this picture, I'll just write as I'm doing it, is that the input 1 gets filtered and gives us the output 2. That's what they're telling us. So the first output here is 2. That's the first element of the range. Right? And then we'll be told that the input 2 gets filtered and we end up with an output 1. So 1 is the next one. And it tells us that 3 gets filtered and it still remains as a 3. That's the last one here. So 3 is our last output. And of course, we can rearrange this to be 1, 2, 3 because order doesn't matter. So here, domain, codomain, and range are all the same thing. Okay. Well, I think that's probably a good place to stop. We have just a little bit more to go before the end of the learning unit, which we can finish the next time. And hopefully when I see you guys next time, I will have your marks ready for you. As you see, there's a lot of marking to do. This is one folder. There's another like 8 like this. So being as quick as I can. Yeah, then I'll see you guys. Have a good weekend. All right.